If you find this video useful, please like this video and subscribe to my channel so that you don't miss any information on mathematics, okay? And of course, you can suggest to your friends as well. All right, so in this session, we'll be solving further examples on the chain rule, all right? So we have two examples. Let's start with the first one. So the first step that we would like to take is to let u be equal to the function under the square root, okay? So that is 5x minus 1, all right? This implies that your y is now square root of u, okay? But you know that square root of u is the same as u raised to the power half, okay? But the chain rule states that dy dx is equal to dy du times du dx, okay? So let's first differentiate the u. We have the u to be 5x minus 1, so du dx should give us 5, okay? Then we got y to be u raised to the power half, so dy du is half u, so half minus 1 is negative half, okay? Therefore, dy dx is the multiplication of this and that. So we would have this times that, okay? So this will give us 5 over 2 u raised to the power negative half. Now u raised to the power negative half becomes square root of u, okay? But u is 5x minus 1. So therefore, dy dx is equal to 5 over 2 square root of 5x minus 1. All right? Let's look at the second example. This is what we have, and we are asked to differentiate. Like I said, let the u be what is under the square root sign, okay? So let u be equal to 2 minus 5x. So y will be equal to 3 over the cubic root of u, okay? This is the same as 3 over u raised to the power 1/3, okay? Which is the same as 3 u raised to the power negative 1 over 3, okay? All right, so the chain rule states that we should differentiate the y with respect to u, and also we should differentiate the u with respect to x, okay? So let's start with this one. So du dx will be equal to negative 5, all right? Then we differentiate the y. So dy du will be equal to this negative 1/3 will come and multiply this. So we have negative 1/3 times 3 u. Now negative 1/3 minus 1 will give us negative 4/3, okay? So this will deal with that, which means we have negative u raised to the power negative 4/3, okay? So the chain rule says we should multiply the two differentials. So we have dy dx is equal to negative u raised to the power negative 4/3 times negative 5, okay? So negative times negative will give you positive. So we have 5 u raised to the power negative 4/3. Okay, so this will give us 5 over u raised to the power 4/3, which is the same as 5. Then the cubic root of u all raised to the power 4, okay? But what is u? U is 2 minus 5x. So you have 5 over the cubic root of 2 minus 5x all raised to the power 4. And you are done, okay? Now let's see more of this example. Find the gradient of the curve y is equal to 2x minus 5 all raised to the power 4, okay, at the point 3, 1. So the first thing that we need to do is to find the gradient function, okay? So the solution, all right. But since this is a huge function, we have to employ the method of chain rule, okay? So let u be equal to 2x minus 5, all right? Then it implies that your y will be equal to u raised to the power 4, okay? So du dx will be equal to 2. That is when you differentiate this. Then dy du will be equal to 4u raised to the power 3, okay? Now, we are to multiply these two because the formula says dy dx is equal to dy du times du dx, all right? So we get dy dx is equal to 4u raised to the power 3 times 2, okay? So we will get 8u raised to the power 3, all right? But we know that u is this. So we have 8 into bracket 2x minus 5 raised to the power 3, okay? This is our gradient function, all right? And we are told that we should find the gradient at the of the curve at the point this. You should know that this is the x and this is the y, all right? So the gradient, that is dy dx, at where x is equal to 3, okay, is equal to, put 3 here, all right? So you have 8 into 2 into 3 minus 5, all raised to the power 3. So you have 8. 2 times 3 is 6. 6 minus 5 is 1. 1 raised to the power 3 is still 1. So your answer is 8. All right?